The night descends upon our blue planet, enveloping the flickering electric lights and the tirelessly computing minds. Yet no one could anticipate that, in mere hours, this veil of darkness would be rent asunder by a blinding radiance, the luminescence of cosmic truth. The narrative we are about to unfold is not a sensational work of fiction, but a stark reflection of the internal simulation scenarios devised by the National Aeronautics and Space Administration, scenarios forged from the most recent scientific data. And it revolves around a terrifying concept. The discovery of extraterrestrial life would deliver a fatal blow to human civilization, not through weapons of destruction, but through a profound shift in perception. Imagine that pivotal moment when the announcement is made. It is not a vague warning, but an unequivocal confirmation. Life exists. Not mere simple bacteria embedded in Martian rocks, but an undeniable chemical signature, or perhaps even an intelligent signal. In the subsequent 24 hours, an unprecedented economic and social phenomenon would unfold. Global stock markets would not merely decline, they would plummet to absolute zero. This is not a panicked response to war or pandemic, it is the collapse of foundational trust. If we are not the center of existence, if we are not the sole intelligence, then the entire system of values that humanity has constructed upon this notion of exclusivity would dissolve into nothingness. The worth of a currency, of a share, of a material asset, all hinge upon scarcity and humanity's preeminent position. When that position is negated, all values become meaningless. In the first hour following the disclosure, internet traffic would surge 1,000-fold. Servers would buckle under the strain. Yet the greater terror lies not in technical failures, but in the societal paralysis induced by this unparalleled convergence of awareness. Billions of individuals, from quantum physicists to ordinary laborers, would simultaneously access the same stream of information, endeavoring to assimilate a new reality. Social networks would transform into a chaotic ocean of data, where nonsensical utterances intermingle with profound debates, not solely due to overloaded infrastructure, but because human nature itself grapples with the most monumental cognitive shock in our evolutionary history. Governments would convene emergency sessions forthwith, not to prepare defenses against extraterrestrials, but to redefine sovereignty, to re-articulate humanity, and to address the most fundamental query: who are we within the grand tapestry of the universe? This perceptual upheaval stems deeply from the accumulating scientific data we are gathering with increasing abundance. Let us return to the planet K2-18b, a world 127 light-years distant, which not long ago was merely a faint pixel in telescopic views, but now commands central attention. In April of the year 2025, scientists at the University of Cambridge announced a discovery that reverberated through the astrophysical community: the presence of dimethyl sulphide and dimethyl disulphide. These names may sound arid, but their implications for biology are profoundly significant. On Earth, these molecules are produced almost exclusively through biological processes, primarily by marine phytoplankton, algae, and certain bacteria. We understand that dimethyl sulphide is a byproduct of metabolic activities in aquatic organisms. The detection of concentrations on K2-18b exceeding those on Earth by a factor of 20 represents an extraordinarily compelling signal. However, subsequent analyses in the latter half of 2025, including those published in July by a NASA-led team in Astronomy magazine and in October by astrobiology researchers, have tempered initial enthusiasm. These studies, drawing on refined James Webb Space Telescope data, found no conclusive evidence for dimethyl sulphide, suggesting that alternative abiotic processes, such as photochemical reactions in a hydrogen-rich atmosphere, might account for the observed signatures. Despite this caution, the debate has deepened our understanding, highlighting the challenges in distinguishing biological from non-biological origins in distant atmospheres. Professor Niku Madhusudan and his team exercised utmost prudence in their assertions, terming it the strongest evidence to date for potential life beyond our solar system. Yet this very prudence underscores the gravity of the finding. The universe harbors chemical reactions unbeknownst to us, but the probability of an inorganic process generating such elevated levels of dimethyl sulphide on a remote world remains exceedingly low, a wager scientists are reluctant to make. K218b is a realm of contradictions and peculiarities. It is not a duplicate of Earth, but a super-Earth, possessing a mass 9 times that of our planet and a volume 2.6 times greater. It orbits a dim red dwarf star, an M-type star, where a year passes in merely 33 Earth days. Its location resides firmly within the habitable zone, where temperatures permit liquid water. Nevertheless, its environment is utterly alien. The atmosphere consists predominantly of hydrogen, a light and ubiquitous gas in the cosmos, yet markedly dissimilar to our nitrogen and oxygen-rich envelope. Surface gravity on K218b would be several times stronger than on Earth. Pressures in the depths of its oceans could reach thousands of times the atmospheric pressure at our sea level. Recent observations from the James Webb Space Telescope in 2025, as reported in Space.com in July, have confirmed K218b as a water-rich ocean world, bolstering the case for habitability by suggesting vast subsurface oceans beneath a hydrogen envelope, potentially shielded from stellar radiation. What might transpire if K218b truly were an ocean world? Scientists speculate that any life there would evolve under entirely distinct physical laws. Vision, humanity's dominant sense, might prove futile in an environment where the feeble red dwarf sunlight scarcely penetrates the dense hydrogen atmosphere. Creatures there could evolve to perceive their world through alternative channels, acoustic vibrations in a dense ocean, thermal gradients, or intricate chemical interactions. Envision colossal beings, perhaps akin to immense jellyfish, drifting in a warm and abyssal sea. Their bodily structures would be engineered to withstand pressures up to 2,400 atmospheres, twice that of Earth's deepest Mariana Trench. Their integuments might comprise biological polymers unimagined by terrestrial biology, fashioned from elements we deem toxic or inert. If such entities, adapted to gravity many times our own, were to set foot on Earth, we would observe them moving with the ethereal grace of supreme ballet dancers, whereas humans, with skeletons designed for one gravity, would be crushed under their own weight on K218b. Yet K218b is but one candidate among innumerable potentials. Consider Teegarden b, a mere 12.5 light-years away. With a 60% probability of Earth-like conditions, it orbits another red dwarf star. Surface temperatures ideally range from 0 degrees Celsius to 50 degrees Celsius, perfect for liquid water. However, Teegarden b faces the challenge of tidal locking. One face perpetually faces the star in eternal daylight, the other is shrouded in perpetual night. Between these extremes lies an eternal twilight zone, where temperatures might stabilize and sustain complex life. The potential for multicellular life here is not insignificant. Recent simulations published in Astrobiology in October 2025 indicate that, with updated stellar flux measurements, Teegarden b avoids a runaway greenhouse effect, reinforcing its status as a prime habitable candidate despite the star's age of 8 billion years and occasional flares. And there is Tau Ceti F, 12 light-years distant, with surface temperatures around 4 degrees Celsius, orbiting a relatively stable star that affords favorable conditions for atmospheric and oceanic stability. As of 2025, its existence remains under scrutiny, with Wikipedia noting doubts from ongoing observations, yet it persists as a super-Earth in the habitable zone. Or Kepler 1649c, over 301 light-years away, also in the habitable zone. Studies in April 2025 on atmospheric ion escape suggest it could retain an atmosphere over billions of years, enhancing its Earth-like qualities. Each of these discoveries is not merely a new data point, they are invitations to rewrite the opening chapters of textbooks on the origins of life. Humanity has developed astonishing instruments to seek these worlds. The transit method, observing a star's dimming as a planet passes before it, has revealed thousands of exoplanets. The radial velocity method detects the minutest wobbles in a star's motion, indicative of gravitational tugs from unseen orbiting bodies. And now the James Webb Space Telescope, with its infrared spectroscopic capabilities, can discern the chemical aromas of distant planets, searching for water vapor, methane, and other biosignatures. In 2025 alone, as detailed in NASA reports from August, it has uncovered evidence for a giant planet around the closest solar twin and observed dramatic atmospheric evaporation on superpuff exoplanets like WASP 107b, where helium clouds trail the planet, offering insights into atmospheric dynamics that could apply to habitable worlds. Nevertheless, we confront a profound paradox, a haunting silence in this vast universe, known as the Fermi Paradox. If the Milky Way harbors hundreds of billions of planets, and if the probability of life emerging is substantial, we ought to have encountered signs of other civilizations, yet we have not, to date. In the year 1950, Enrico Fermi posed the classic question over lunch: where is everybody? Explanations for this silence abound. Perhaps we are unique, a fortuitous anomaly, a cosmic lottery jackpot. But that seems overly complacent for a universe that favors diversity. The zoo hypothesis offers another perspective. Perhaps they have known of us for aeons, but adhere to some non-interference directive, or simply deem us insufficiently significant for contact. The technological gulf between us and them might exceed that between humans and an ant colony. Would you pause to expound physics or mathematics to an ant? The distance hypothesis posits that even with millions of civilizations, the separations are immense. If 100,000 civilizations are evenly distributed in the Milky Way, the average distance between nearest neighbors could be 5,000 light-years. At light speed, an encounter would require 5,000 years, a span exceeding the lifespan of any known civilization. But the most discouraging hypothesis is the Great Filter. The inception of life is one filter, and on Earth, complex life is another. Yet further filters loom ahead. Climate change, nuclear war, global pandemics, or the unchecked rise of artificial intelligence. These cataclysms might extinguish civilizations before they reach the stars. If that filter lies before us, the universe's silence warns us of our own peril. And then there is the dark forest law, a chilling theory that the universe is perilous and advanced civilizations must conceal themselves meticulously, uncertain of others' intentions. They must strike first for self-preservation. However, this theory fractures when applied to humanity. We are not hiding. For over a century, we have broadcast potent electromagnetic signals into space. Television, radio, and radar emissions have propagated at light speed, forming a radio bubble with a radius exceeding 100 light-years around Earth. Any civilization within that range has long known of our existence. We have exposed ourselves. Our instruments persist unabated. The 500-meter aperture spherical telescope in China, with its colossal dish, listens for whispers from distant galaxies. Project Ozma, initiated in 1960, paved the way for this quest. The Pioneer and Voyager spacecraft, our metallic emissaries, carry golden records etched with human images and sounds, voyaging into interstellar space. In 1974, we actively transmitted a radio message to the M13 globular cluster, 25,000 light-years away, an act bordering on communicative suicide, for any reply would take 50,000 years to return, far outstripping our current civilization's longevity. We are conversing with our distant future or with utter strangers. Occasionally, humanity errs. In 1998, anomalous radio signals from the Parkes Observatory excited scientists, but after 17 years of scrutiny, they traced the source to a forgotten microwave oven in the observatory's break room. That blunder reminds us of the fragility and solitude we strive to transcend. Yet the urge to search endures. Since humanity realized we are not merely dwelling on the ground, but adrift in an infinite cosmos, the thirst for exploration has become our core essence. We have crafted the most sophisticated tools to probe the boundless voids, dispatching messages and hopes into the void. If the signatures on K218b prove genuine, if the dimethyl sulphide compounds are confirmed as biological products in the coming 1 or 2 years, amidst the ongoing debates of 2025, where astrobiology journals question abiotic alternatives while others uphold the biosignature potential, that would mark a history-altering moment. Certainty would supplant doubt. We would no longer contend with hypothetical scenarios. We would possess direct evidence that life is not Earth's exclusive domain. At that juncture, the stock market collapse would be but a superficial symptom of a deeper civilizational tremor. The true shock would be humanity's repositioning in the cosmos. We would cease to be the sole arbiters of intelligence. Our entire frameworks of philosophy, religion, and science would face challenge. We would accept that other beings exist, perhaps wielding intellects beyond our comprehension, existing in manners we can only dimly envision. Recent developments in Fermi Paradox theories, such as the bored aliens proposal from October 2025 in The Guardian, suggesting advanced life has ceased efforts to contact us due to disinterest, or the mundanity explanation from Archive in September, positing a modest number of technological civilizations with limited expansion, add layers to this enigma, reminding us that silence might stem from apathy or scarcity rather than catastrophe. As we gaze upon K218b, no longer a distant speck, but a world potentially teeming with living entities experiencing the universe under their own physical laws, the gulf between us and them remains insurmountable in the short term, a span of 127 light-years, but their existence has already narrowed the perceptual chasm between us and the universe's grandeur. This cosmos, with its intricacies, with bizarre worlds like K218b and Teegarden b, is unveiling new horizons. Humanity's quest for life beyond Earth is not a pursuit of rivals or allies, but a journey to uncover our own identity, a journey that may be nearing its climax. And when truth is revealed, whether absolute solitude or unforeseen companionship, human civilization will never be the same. The cost of this awakening might be the downfall of economic systems, but the reward is the boundless expansion of human awareness.